We're going to look at another application of exponential equations, and this is dealing with radioactive decay. So here we have a sample of radium-226, and this element has this isotope has a half-life of 1,620 years. If the original amount was 5 grams, we're asked how much would remain after 10,000 years. Okay, so the first thing we need to recognize here is that we have some radioactive material and it's decaying. And radioactive material decays according to the law of exponential decay. And so we have a template for a mathematical model for the way this amount of radium decays throughout time. And it's given by the following equation. We have CE to the KT. C here is the initial amount. We have that 5 grams. K is a constant that tells us how fast this decays. We can get that through this half-life, knowing the half-life here is 1,620 years. And the amount remains here, and that's the time it's left to decay. Okay, so let's go ahead and first off build this equation. Then, once we have this ready to go, we will evaluate it at 10,000 and then look at the amount. Okay, so the first step is to build this equation. So we need the K. We have the C, it's 5 grams. And we know, since the half-life of this radium is 1,620 years, if we wait 1,620 years, this 5 grams will decay to 2.5 grams. So let's set that up. So we have 2.5 grams, 5 grams, e to the k, which we don't know, times the number of the time here, 1,620 years. All right, so this is true. So if we wait this long, this 5 grams will turn into 2.5 grams. All right, now we can solve for this k. All right, first off, divide by 5 gives us 1/2 equals e to the 1,620 k. Apply the natural log to both sides. So we have the natural log of 1/2 equals, and the natural log and e cancel, gives us 1,620 k. And then we can divide by 1,620. All right, so that gives us our finished model for this particular situation. The amount remaining after T years of this radium is 5e to the natural log of 1/2 over 1,620 times T. Okay, and now we can use this to answer the question. How much would remain after 10,000 years? Well, the amount after 10,000 years is going to be 5e to the natural log of 1/2 over 1,620 times 10,000. Be careful when you put that in your calculator. If you do, you'll get approximately 0.07 grams. So a whole lot of it compared to the original amount. All right. When you do put this in your calculator, make sure that you put all of this in at once, and you should get this right here.